this series on the number representation in the real and digital world. In the analog world, we see that we use decimals to represent various quantities of measurement, whereas in the digital world, we use binary. But in order to make binary more easy to read and write, we use hexagonal decimal for most of our coding. Um, in this final part, we'll be looking at binary coded decimal. This is slightly different from the binary that we have talked of earlier. In the earlier binary representation, the binary number represents the whole value of the decimal number. So for example, in this case, 78 base 10, the whole value of 78 is represented by this binary number 01001110. However, in the case of binary coded decimal, it is quite different. The we do not the binary coded decimal does not represent the whole value of the decimal, but the individual digits. So for example, in this case 78 base 10, we do not try to find the value of 78 base 10 using the positional value method to get the binary value. Instead, we split the digits up into 7 and 8. Okay, into 7 and 8, and then let's look at it. 7 and 8, and for each of this decimal digit, we convert it into its binary equivalent. So for example, 8, we will convert it to the binary equivalent, which is 1. Sorry. So to do the binary conversion, again, we use the positional value method. So this is 1, 2, 1, 2, 4, 8. So this will be 1, 0, 0, 0. And again, the same thing for the other side. 1, 2, 4, and 8. Now, since 8 cannot go into 7, so this is a 0. 4 can go into 7, this is a 1. You have a remainder 3. 3 can go, 2 can go into 3, so that's a 1. And so there's a remainder of 1, and 1 can go into 1, so there's a 1 here. So the binary coded decimal equivalent of 78 base 10 is equals to 0, 1, 1, 1, 1, 0, 0, 0, B, C, D. Next, we convert the BCD the number to decimal. So again, we're starting from BCD. We got 0, 1, 1, 1, 1, 0, 0. The first thing that we need to do is to split the digits, group them into 4 and split them. So let's do this. Split them down the line here. And then when we split them, again we will use the positional value theorem, place them in their positions, and here see that where there's a 1, we bring it down. Okay, so we bring 4, 2, and 1 down. All right, and then we add them together to get a binary, a decimal 7. And then the similarly for this, we have only 1 here, the rest are zeros, so we just need to bring it down. Bring it down, and that will give us the number 8 over this side. So we combine them together. This will give us 78 base 10. So this BCD is equals to 78 base 10. All right. So if we want to convert BCD to a hexadecimal or a hexadecimal, we first need to convert BCD to decimal, and then we convert it to binary, and then to hexadecimal. Similarly, if we want to convert a hexadecimal to BCD, we first need to convert to binary, then to decimal, and finally to binary coded decimal. I hope this gives you a clear picture of the ways of going about converting from one digital system, one number system to another. Okay, and we just basically use the positional value method. Right, please post your questions in Facebook if you have any. Thank you.